The B4X ecosystem, covering B4A, B4J, and B4I, is built for speed. It has a long-standing reputation as a high-velocity environment where developers can rapidly stack components to build functional, cross-platform applications. But as projects grow, a structural limitation appears. The classic B4X language lacks several modern object-oriented features, most notably class inheritance. This usually isn't an issue for small utilities. The friction only starts when a project scales into a complex interactive game, a custom UI library, or a large-scale enterprise application. Without inheritance, developers have to manually rewrite the same foundational logic for every new component. You end up with towers of redundant logic, the same position, size, and movement code copied over and over again. At this scale, the developer's time shifts away from solving new problems and toward the repetitive maintenance of boilerplate code. The ideal solution is clear: the clean, modular organization found in modern object-oriented programming. However, most developers are unwilling to leave the B4X ecosystem. The official IDEs and native compilers are highly optimized and already handle the heavy lifting of cross-platform deployment. Switching to an entirely different language just for better syntax is a massive risk. It breaks existing workflows and makes years of legacy code obsolete. This leaves a gap in the workflow. How can you use expressive modern syntax while keeping the native compilers you already trust? B4X++ is an experimental precompiler designed to bridge that gap by adding a modern syntax layer on top of standard B4X. To see the impact on a real project, we can look at a breakout game built in B4J. Every time the ball strikes a brick, the system has to process velocity, collision bounds, and screen coordinates. The game is built from 3 core interactive parts: the ball, the paddle, and the bricks. In classic B4X, each of these objects would require its own separate code module to track basic data like X and Y coordinates. If you wanted to change how the game handles screen scaling, you would have to update that math in 3 different places. While manageable for 3 objects, the workload multiplies as you add power-ups, different brick types, or complex scoring overlays. Every new feature increases the manual maintenance burden. B4X++ solves this with a base class. We put shared logic, position, size, and rendering into a single game entity class. The ball and paddle extend that class, instantly inheriting those properties without extra code. This lets child classes focus only on unique behaviors. The source code stays even cleaner thanks to modern property syntax, which handles variable access automatically. By organizing the project this way, we eliminate redundant code and keep every class focused on a single, clear responsibility. But if the official B4X compilers don't support inheritance, how do they run this code? The secret is that B4X++ is a source-to-source precompiler. It processes your modern code before the official IDE ever sees it. The precompiler reads your rich source files and flattens the hierarchy. It automatically generates the standard B4X modules, the .bas files, that the official compilers expect. This shifts the burden of writing repetitive, legacy-compatible code away from the developer and onto the machine. This source-to-source translation logic applies to web development as well. B4X++ integrates with the Banano web framework, allowing developers to use OOP features for browser apps. It generates the necessary HTML, CSS, and JavaScript, adding modern async and await features. The result is a unified development experience where the same modern syntax can target entirely different platforms. The developer gets a modular, expressive workspace, while the machine receives the standard native code it requires. This follows the same logic as TypeScript. It provides a structural layer for the developer that compiles down to the native standard for execution. It shows that you don't have to abandon a reliable ecosystem to gain modern features. By using a precompiler layer, developers can utilize modern organizational tools while continuing to build on the established B4X compilers.